Get them in with the green screen.
Okay, next up to fill in the rest on using the satellite and the radar imagery, Gary Hufford. Gary is taught here at UAA for over 20 years, but he was also was it the NOAA chief scientist
I was the
here?
original scientist for the Weather Service.
And he actually wrote some of the code.
23 years.
He actually wrote some of the code that the satellites use to send the information back to Earth, so widely published. He's gonna mic you up with the that mic. And if I could just make an editorial comment, they really have produced some fantastic weather products now. But it kind of reminds me of the late 70s, early 80s, when they started giving us programmable flight displays in our fighter aircraft. And you could change what the buttons on your throttle and stick did, and they would change the displays and everything. Well, you could be a pig in space really quick if you didn't know what you were doing. And the upshot of this is, you just need to go to these websites and spend several hours there and figure out what works for you. Write it down, right? Kind of have your checklist so that you go to the places that are useful to you and you stay away from the ones that, it doesn't sing to me, that one doesn't work. But it's really incumbent upon us to dig into this stuff and figure out what we like and what's useful. And then, just like with our airplanes, procedurally, we got to do the same thing all the time. So you go to the sites that work for you, you do the same thing all the time, and it saves you a ton of time. But it's painful at first until you can figure out what you want to do. And with that, over to you, Gary.
Thank you. Excuse some of my movement. I had surgery here recently and my legs are wrapped up like a mummy, so if I walk funny, it's not that I'm drinking. I gotta wear these for another week. Basically what I wanted to cover today with you folks are two observations that are incredibly important as far as I'm concerned, and I think you too, when it comes to making that final decision about going. Do I fly or not? And that ends up being the weather radar we have here, as well as satellite. And satellite is something that was one of my specialties. Some of the things I worked on, in fact, I'm a co-author and one of the producers of a algorithm that's used on the satellites now to determine the water equivalent of the snowpack in California, in the Sierra Nevada, so they know how much water they may have for the coming summer. Okay? So satellites and I have had a long-term relationship. I think it's interesting that we always talk about the meteorologists and well, are they doing well or not with their forecast? How many of you are aware of what the date was for the first weather operational satellite in the United States to go up? April Fool's Day, 1960, an appropriate date, okay? Those satellites back then were a passive, which meant that it was simply looking at a scene and you were seeing that photograph, if you will, of it. And the typical things that you were looking at the spectrum make sense. What's the major source of energy to the atmosphere? Ultimately, solar radiation. So shouldn't I look at solar radiation in the visible? There's your one sensor. The other is the Earth, in turn, also gives off heat because it's a black body. A term we use in physics for objects that give off heat. So shouldn't I look at infrared? Because that's what it gives off. There's your other sensor, all right? But since that time, we've been able to, with the technology, to move into the era of no longer the passive, but the active sensor, where I'm actually sending a pulse down and receiving back information, okay? So now I'm looking at things well into other parts of the spectrum I couldn't look before, okay? And in fact, that first satellite went up, had 5 channels of information. NASA's latest satellite has 2,300. Okay, now that's a quantum jump, okay? And so I'm gonna end this talk with a site that's pulling that data down all the time. And you'll see the source of where to get that information on the internet, in which here in Alaska, because of its remoteness, one of the very few things we need to rely on is the satellite data. But before we get there, let's take a look at the radar, because one of the things that drives me nuts is watching our local TV at night and watching them talk about their interpretation of what they're seeing with the radar, and which tells me they don't know how it works, okay? And so this is just a little reminder for you folks, okay? The Doppler radars, and why we have them, and why we don't have more than in the original plan of the National Weather Service. There was never to be any Doppler radars in Alaska, Guam, or Puerto Rico, or Hawaii, okay? And the main reason was for this. One of the main purposes of the Doppler radar, weather radar, is to look at water droplets. In fact, its sensitivity is such that it can see a raindrop 240 miles away. Okay? Now, if you remember some of the things you learned about precipitation when you were looking at weather, you found out that really there's only 3 kinds of rain. There's stratiform, there's cumuliform, and there's cumuliform embedded in stratiform. Can I take advantage of that? Yeah, because immediately if we think about it, stratiform rain is what? Small droplets. Cumuliform rain. You sure know when you're in cumuliform rain when it hits your windshield when you're driving with a big spot, big water droplets. Okay. So what ends up happening is this radar is actually looking at size through the reflectivity. That is sending out a signal, getting a return. Sensitivity, minus 1/14, 10 to the minus 14 to come back, which means it's an incredibly sensitive unit. The only reason we have the units that we have with Senator Stevens, I see enough gray hairs in here to remember Stevens. You also know that Stevens lost his wife in a accident landing at Anchorage Airport back in 1974, I believe it was, okay? So Senator Ted always had a great interest in weather for the state because of his own personal experiences with it, okay? So what ended up happening is always the government kind of overbought. And the reason it kind of overbought is that when we went to Congress and asked first as Weather Service to put in the radars, the budget, we were turned down. So it's way too much money. We've got to come back with a better argument. So we formed a triad with the Air Force and the FAA, okay? And so as these were put around the country, as well as where the Air Force was actually putting them at Air Force bases in foreign countries, we ended up getting what I call leftovers. For instance, Fairbanks antenna was meant for Frankfurt, Germany. The radar that's down here at Nikiski, here for the Kenai radar, was meant for Seoul, Korea, okay? So the only reason I bring this to you is that often people say, why don't we have more radars? Because when we did the analysis to cover Alaska like they cover the lower 48, we need 27 radars, okay? And there was a number of reasons why we couldn't get more, a couple more. First off, they require a great deal of power. Classically, the radar out here, aircraft radar at the FAA runs, it's at 50 kilowatts. The radar is 750. Can you imagine trying to go to a village like Kaliganik, let's say, in Bristol Bay, and ask for that kind of power from the village to run that radar? Impossible. Okay? So that became a limiting factor about where we could put them. Number two, another problem came in the fact that in the lower 48, we started putting them in California, and it just so happens that one of these radars went into the backyard of Mr. Hagman. If you don't remember that name, he was the villain on Dallas, the TV show. And when he started hearing the rumors about the radar, he found that it was going to have such an intensity, being able to see a raindrop 240 miles away, that if his thing is only a mile behind his house, it's going to fry his house and fry his eggs for him. Okay, so he's one of those that took us to court, and one being a TV star he was, and the Weather Service has never been able to actually operate the radars below 0.5 degrees. And they're capable of going to negative elevations. Why is that important? It means that if I put one of these on the top of Pedro Dome in Fairbanks at 2,000 feet, am I ever going to see those low clouds over the airport? No. Okay? So the location of where the radar is, its elevation, is something you have to give some thought to. Okay? Now the reason we put it up there is that the main driver for the Fairbanks is flooding. Okay? The reason why this got all the attention for the lower 48 with none for Alaska is what's the severe weather for the lower 48? Thunderstorms. Large water droplets, right? Now I've got a radar, I can look at that. Okay? And I can use that. So if you got any questions as I'm going along, feel fine. Can you reflect the next one for me? Okay. Here's the real key. Remember I said that signal comes back as reflectivity. And we can take those reflectivity values and we can, in fact, calibrate them in general. And basically what it means is that any time 15 or less comes in from the radar, we're going to assume they're clouds. Value somewhere around 15 to 29 is going to be light stratiform. Okay? 30 to 39 is going to be moderate stratiform. And anything 40 or larger is going to be cumuliform precipitation, which immediately tells you what you learned way back in, when you were taking your weather course for your pilot. Okay? You know the weather associated, it's different with them. Vertical motions, for instance, turbulence, downdrafts, wind shear, okay, etc. So now all of a sudden I can take a look at those colors, and what's important is not the color I'm using, but what color is attached to the table to give you those values, okay? And then you can see that we go up into a heavy, very heavy, and all the way up to extreme. Now, what is the largest object you think you can measure with that radar, if in fact it's so sensitive to water? Anybody know? Hail. Hail, because how's hail work? Up it goes, right? The water, the droplet rises, it freezes. It gets heavy, and the updraft is not like a vacuum cleaner. You see it sears with a blow, okay? It fluctuates. And so now that hail drops down into warmer temperatures and does what? Gets water coated, the radar sees it. So now I have an opportunity to not only know I've got convective activity, but I may have hail. And then I may have an extreme system that could in fact produce a tornado, okay? So, when you're looking at that information now, and here's a rough typical example I use in teaching a course here. We can look at those colors and immediately we can see that there is that green. I can go to the green, I see it's 25 roughly, and so I'm talking about like precipitation. And that kind of precipitation is stratiform, and it fits what you learn. It's uniform, widespread, okay? And the blue around it are less than 15, and so I've got what? Clouds, okay? Next slide. Now if I take a look at this, all of a sudden I see exactly what I learned about convection. Singular clouds, okay, that are changing in vertical height very rapidly over time. And so I should see many colors associated with it because I have a cloud that's extending rapidly vertically. And so I can take a look at these and I can see here that I have some squall lines. We define squall lines as where there's a line of thunderstorms where the line is filled by more than 60% of the thunderstorms. Okay, so now I can pick those out, all right? So, now I know I'm looking at stratiform rain, the kind of weather can be associated with that. Typically what? Affects visibility, cloud height, okay? Potential for aircraft icing, okay? Updrafts, weak, but I may still have chop, okay? If I now look at this data, I know that I now can look at that whole severe basket of nasties that go associated with a thunderstorm, all right? Now, we're looking at those, but what do I know about their actual height? If I look at the next slide, this becomes a very important. This is the relationship between the radar at the different 14 elevation scans that the radar can work at, okay? And we see the 0.5 as the lowest. What I have on here is that a little cutoff down here at the bottom, but it would give you the distance, okay? So that if I went out here at about 60 miles, and I'm looking at the lowest scan, and where is the radar for Anchorage? Nikiski, how far is Nikiski away? Roughly, let's say 50 miles, right? That means that if I'm trying to give an idea about what the height of what I'm looking at is, I go out here to 50, I go to the middle of the beam, and I go over to the side and I find out that I'm already up at what? 6,000, 7,000 feet. What's that mean then if there's clouds over Anchorage at 3,000 feet? Are you seeing them with the radar? No. And if you're looking at those clouds that are all the way down near Kennedy entrance, into Cook Inlet, which is now what, pushing 200 miles, all of a sudden we're talking about being where? Way up there. Okay? Be careful on how you're interpreting what clouds may be there. That doesn't mean that the radar isn't a fantastic tool, because it is. But it needs to be looked at with other information. And often the best tool for that is what? Satellite data. Because the satellite data now is going through a transformation that's just amazing. All right? There are so many channels of information that are now coming up that it's unreal. Any questions about that radar?
I got one question.
Yes.
So you talked about those limits based on the distance. Sometimes I just click on what's called composite.
Yes.
So is the composite mixing the radar with the satellite?
No, what the composite does is it takes the highest DBZ value. Okay? Let's say that I'm looking at a convection cell, and at the top I'm around 20 dBz, somewhere around the middle, 3/4 up, I'm at 55, okay? And then I'm down in the 30s or down to 50, lower values yet. What the composite does is we'll choose that high value and plot it. And so when you look at the composite, it's telling you, I gotta go look at that site with more detail. Okay? All it does is gives you that rapid look to say, there's a hazard if I'm worried about convection. All right? Now, one of the things we've been limited up here with is that we've got the whole horizontal polarization issue. We're now in the south, the lower 48, they've been upgraded to dual polarization, which means they're not just limited to looking at water so much anymore. It now has the ability to look at a lot of goodies. In fact, debris in the atmosphere that really is important, because it can tell us now that I don't only have a convective cloud that has a potential for a tornado, there is a tornado and it's on the ground. Okay? One of the reasons, again, like I say, we haven't got things, we were always in the back door for getting the radar. And I wish we had more, because there are some key places around the state where radar can still play a big role. If we go to the next slide, if there's no more questions about radar, I want to hit satellite. And we have some good satellite imagery overall that you see on the Weather Service sites, okay? And other sites, commercial, etc., okay? But one of the places that we happen to have a unique set of information is right here in Alaska. And this is GINA. And GINA, as you can see by it, the acronym of, and the website, was put together when, in fact, NASA needed a field station to look at the data. And these field stations are located all around the world. Okay, there's one in Australia, for instance, where you go down that looks at all polar orbits as it goes over. You can make adjustments to orbits, etc. The point here is that GINA was put in and is funded by a number of federal agencies, like the Department of Interior, NASA especially, and our own state of Alaska. So you're seeing our state money being put into a situation there where they have the antennas located both, if you've ever been to Fairbanks, you can see the antennas on top of the IARC building and GI building, okay? And those that are out at Gilmore Creek, or those that are also out at Poker Flats, all right? The beauty about the site is that one of the really nice things that keeps down costs when you have graduate students is you have a slave. So one of the things is this is operated 24 hours a day, 7 days a week by graduate students, okay? I know this well. I did the slavery myself when I was in school, and but it was one of the ways that it helped pay for the scholarship I had, et cetera, but also to provide some really important information. So if we go to that site, and click on that blue.
You may have to, nope, there it is.
There it is. Okay. And now what we can see here is some of the information about the site. What I really like about this site, and what I think is really important, is that it was written for the general community out there. So the training material that's on the site, I think is just spectacular, all right? I don't have it on the screen here, but I can go
Training
on here.
resources right in the middle, Gary.
Hmm?
Training resources in the middle. Bottom of the black
Oh, yeah,
square.
can you? Hit products, yeah. And if you go down, here's each one of the single bands and why and what they do, all right? In fairly simple language, not high level, and can tell you. For instance, how many are you aware now of the new day-night band? Where I can actually look at the cloud cover over Alaska at night. And I don't have to rely on the old military technique that we used off the DMSP here in Alaska. In fact, we were the only Weather Service office for years that got real-time DMSP right out of Elmendorf. In fact, we were the only office. That's something I was pretty proud of, maybe because that was classified data back at that time, okay? That required a quarter moon or more at night to see clouds at night. This is totally different. So, you're talking about your planning. What a unique way to take a look at just, I'm worried about this cloud band coming in from Bristol Bay, moving into South Central. And I'd like to know where it is just before I go to bed, because I'm gonna get up pretty doggone early tomorrow and take that flight. I can take a look at the day-night, that nighttime visible imagery and see the clouds, all right? A really useful tool. And it's also neat because it also, off and on the imagery, up will come bands of the northern lights, so you know when there's northern lights out too. I don't worry about their forecast. I go to this site. Yeah, if there's northern lights, it's about look. Okay? The other thing is that you can find out where we're wasting electricity across the country, the state. I can pick out every village that leaves their lights on with that nighttime visible, all right? You can see Prudhoe Bay lit up like a Christmas tree, all right? Just to give you an idea of the kind of tools that are available on there. If we go back, click back, Mike, to the third page, go to real-time data, and if you come down, before you click on it, notice this one, aviation and cloud. Okay, click on that a minute. And look at the number of products that you can get on cloud cover here's clouds of day-night band up above, et cetera, et cetera. You can click on that, et cetera, and get the latest satellite path, all right?
There's a lot of stuff I scrolled down through here already, and it's like, where do you go? There's like, I don't know, 100 different.
Right, there is,
You
and one of the
scroll
ways
down
that you
there.
can limit
So
that
where do
is
we-
go back
I mean, you never
now
scroll to the bottom of the page, that
to
just
that,
keeps going and going
the
and going.
list we just had. And when you go on down, hit Puffin Feeder, this will tell you exactly what is the latest passes available and from what satellite.
Is that old data then, that's below, what are all those different rows?
Oh, that was, yeah, just to show you, here's the latest right here,
Okay.
okay? I can come down, I can go through, and you can see where the patch is. Because remember, polar orbiting data is different than the geostationary. The geostationary is up there at 19,000 miles, rotating at the same rate the Earth rotates, so it's always looking at the same spot. That's why we have goes west at 135, and we have goes east at 75 degrees west longitude at height, okay? Whereas the polar orbiter is about 450 miles up, going around the Earth about every 110 minutes, okay? And as it progresses around and crosses the equator, it shifts 25 degrees. Okay? And which means therefore, I don't get imagery every 15 minutes or 20, but because there's so many satellites following each other now, I can in fact get data that is where I'm looking at information on about hourly from at least one satellite or another, all right? So what I'm suggesting here is that take a look at that. If it comes to one of those situations where you find it a little more complicated, I certainly would have no trouble working with my compatriots up at Gilmore. We put together a satellite course seminar one day where we can go through that in real detail, so that you can get the total use of that information out there, because there's all kinds of stuff in there. For instance, hey, you still got your skis on. You want to know, hey, is that lake up yonder I like to go still ice covered? And if it's ice covered, how thick is the ice? This has a snow ice algorithm in there that'll give you that kind of feel that you know what you're looking at, all right? So now, and again, hey, I got my skis on. Is there still any snow up at the area that I can land on, let alone lake? Okay. So what ends up happening is we have this kind of tool right here in this state, and I surely highly recommend you go to the site, take a look at their training materials. I think that you'll find that they're fairly straightforward, okay? And away you go. Talking about things that we can put on the safety foundation, one of the courses I put together here back in the late 90s for especially the air traffic controllers, was to take the introduction to weather course that I taught and take that to the next step of how now do I take that weather knowledge I just learned and work with weather products. And I called the course Tools for Weather Forecasting, in which the basis of the information was on the FAA's total training material at that time from their site in Oklahoma City. Okay? Yeah, if you can stick that. Yeah, go to school. Okay? And for instance, we just talked about radar. Okay, and as you can see, here's the material. It's getting aged a bit, but still standard, but what you can go through here. And remember, the reason why this is nice to learn on is the fact that it was written for air traffic controllers, not meteorologists. So it's not what I call that high level, okay? But I've got everything in here that allows me to take a look.
Yeah.
At exactly how the radar works. And what's important is it tells you what the key information that you should be learning. Okay? A little bit about how the radar used to work. And I just want to go down here low enough to let you see the kind of information that you see about that radar. And then it has another section on radar interpretation. So it lets you see how to look at a stratiform precipitation image. It also lets you look at the cumuliform. It allows you to look at the fact that you can see some interesting meteorological features. For instance, one of the things that I've always enjoyed looking at is the gust fronts associated with thunderstorms. They really show up nice on the radar. Okay? And there's another little capability that's interesting. Remember I said that when you see those colors on there in interpretation, one of the things we looked at was the yellow for 40, which is a convection. And what I'll watch them talk about is, hey, look, there's some convection in the imagery when I see this yellow all embedded in over a large area, not singular cells like convection should be. What am I looking at? And one of the things that bothers me, because it's a neat little tool. What it is what did we talk about? Snowflakes, like we did with hail. What happens to snowflakes as the snow's formed aloft and now it drops into warmer air? What's going to happen to the snowflake? It's going to get water coated as it melts. That's when it's picked up by the radar, and now I see a feature we call the bright band. And the bright band showing up of that yellow all spread out there tells me what? Approximate height of the freezing level. Because that's just when the snowflake is beginning to melt, all right? So the radar has a lot of unique features. This training material takes you through all that, okay? The other part I wanted to show you, if we go back to school, I think that what, yeah, all the way down to school, yeah. Hit weather analysis here. And what I want to show you here is material on there that I think most of you will find very useful. One of the problems that I've seen is that we made a fairly rapid movement towards self-briefing. Self-briefing to me means I have some understanding of what I'm looking at, okay? Unfortunately, that's not always the case, right guys? So here I have a situation in which I have a little segment in nice plain English on everything from pilot weather briefing, what goes into a pilot weather briefing in what order. And then all of a sudden I have everything in here from vertical motions, stability, weather producing systems, clouds and precipitation. So I got a little snippet on all the weather, which is something you can go to if all of a sudden you're looking at this and hey, I can't quite remember all that was on something, let's say about the clouds, all right? Here you can go back, and this now becomes your reference. So you don't have to own a meteorology textbook or go all over the place, because one of the problems that the federal government's always had is one-stop shopping. It doesn't seem to know how to do it. Okay? All right? Any questions? Because what I want to do is we can talk with the safety fund, how you can get that information,
So that's gonna be,
okay? Because that's easily put on a website.
oh, okay.
In fact, when you took my course, I gave you a thumb drive with all that for you to keep, okay? And something that you can always turn back as a reference. And so here's two of the observations out there that you really want to take a look at. At that last minute, make your decision about go or no go. And that is the radar and the satellite. All right? Thank you.
Thank you.